Wow, SpaceX has just unveiled the full scope of what's coming with the next Starship flight, and the details are nothing short of stunning. From bold upgrades to surprising changes in design and testing strategy, this mission is shaping up to be one of the most pivotal moments in the program's history. There are breakthroughs to celebrate, challenges to overcome, and plenty of developments that could redefine how we think about the future of Starship. But while excitement builds in Texas, not every company is enjoying smooth progress. Over at Firefly, the Alpha rocket is facing fresh setbacks, with delays stacking up and a recent test ending in failure. These struggles highlight the contrast between rapid advancement and the harsh realities of rocket development, reminding us that in this industry, progress never comes easy. So buckle up, because in today's episode of Great SpaceX, we're diving into all of it, from the thrilling surprises from SpaceX's upcoming flight to the turbulent road ahead for Firefly Alpha. Speaking of surprises, the countdown to Starship Flight 11 is picking up speed. The hardware is coming together at a remarkable pace, and with that progress, new details about the mission timeline and objectives are beginning to surface. What everyone has been waiting for, though, is the official word from SpaceX. And now, those long-anticipated updates are finally starting to arrive. On September 29th, SpaceX announced on X, Starship's 10th flight test took a significant step forward in developing the world's first fully reusable launch vehicle. Next up, Flight 11 of Starship is targeted to launch as early as Monday, October 13th. That is right. The launch date has now been confirmed, and it perfectly aligns with the first day in the local Notice to Mariners launch window announced earlier. In addition to this, SpaceX specified the exact launch time as 6:15 p.m. Central Standard Time on October 13th. If everything goes according to plan, Flight 11 will take off on the same day that Flight 5 did, the historic flight that successfully caught the booster for the very first time, ushering in the era of Starship's partial reusability. Over the past year, SpaceX has clearly made major strides, so mark your calendars, because this is a mission worth remembering. Now, let's walk through all the details for Flight 11. SpaceX stated that the upcoming flight will build on the successful demonstrations from Starship's 10th flight test. The mission will include experiments to gather data for the next generation Super Heavy booster, stress testing Starship's heat shield, and demonstrating maneuvers that will mimic the upper stage's final approach for a future return to the launch site. As many anticipated, Flight 11 is designed to be highly experimental. This will be the final flight of the current Starship version, serving as the bridge to the future fleet of upgraded vehicles and new missions, such as catching the entire rocket stack. Now let's go ahead and break it down phase by phase. According to SpaceX, the booster on this flight test previously flew on Flight 8 and will launch with 24 flight-proven Raptor engines. Its primary test objective will be demonstrating a unique landing burn engine configuration planned for use on the next-generation Super Heavy. It'll attempt this while on a trajectory to an offshore landing point and will not return to the launch site for catch. This means that out of 33 engines, 24 are being reused. Only 9 engines will be brand new, and that includes the 2 middle ring engines that failed during the boostback burn on a previous mission, although one of those did restart during the landing burn later. The additional 7 engines are being replaced, most likely because SpaceX identified them as potential risks. The major highlight is the landing test. The booster will once again land in the sea rather than being caught, although many speculated that October 13th might signal the first attempt at a catch. Safety and success remain the top priorities, especially on a test-driven mission like this. For the burn process, 13 engines will ignite to begin the landing burn as seen in earlier flights. After the initial deceleration, most will shut down, leaving only a select few engines to guide the vehicle. On past flights, 3 inner gimbal engines were kept for navigation. This time, however, 5 engines will handle the task, which likely includes 3 inner ring engines and 2 middle ring engines. This change is significant. Booster V3 will rely on 5 engines for final descent, which adds redundancy in case of spontaneous engine shutdowns. By testing this configuration now, SpaceX is preparing for greater reliability in future catch attempts with the Mechazilla arms. Finally, for the terminal landing phase, a 3-engine configuration will reignite to complete a controlled hover just above the ocean surface before shutting down and dropping into the water. This marks a shift away from the 2-engine landings we saw previously. SpaceX summarized the goal, which is to measure the real-world vehicle dynamics as engines shut down while transitioning between the different phases. Turning to the upper stage, Flight 11 will carry forward several objectives. The vehicle will once again deploy 8 Starlink simulator satellites on a suborbital trajectory. These satellites will later self-destruct during re-entry. In addition, an in-space relight of the engines will be attempted, continuing the critical work of proving Starship's orbital capabilities. More importantly, SpaceX has emphasized that this mission will prepare Starship for future returns to the launch site. Catching the upper stage is one of the most anticipated milestones, expected to debut as early as next year, possibly between Flight 13 and Flight 15. The most daring element of the test is the heat shield. According to SpaceX, for re-entry, tiles have been removed from Starship to intentionally stress test vulnerable areas across the vehicle. Several of the missing tiles are in areas where tiles are bonded to the vehicle and do not have a backup ablative layer. This is a bold decision. Many expected that the heat shield would finally be tested in a fully installed state. Instead, SpaceX has deliberately left weak spots exposed. This move demonstrates confidence that the vehicle can survive even if tiles are lost during flight, a realistic scenario for future missions. In addition, Starship will attempt to replicate the trajectory it would take when returning to Starbase. SpaceX explained the final phase of Starship's trajectory on Flight 11 includes a dynamic banking maneuver and will test subsonic guidance algorithms prior to a landing burn and splashdown in the Indian Ocean. In simpler terms, the ship will rehearse guidance and maneuvering steps such as banking, flipping, and steering into a controlled landing zone. These are essential rehearsals for eventual returns and catches at Starbase. When we step back, Flight 11 represents much more than just another test. It's the culmination of lessons from the first 10 flights and a forward-looking mission that sets the stage for the new generation of starships. The focus is now shifting to catching both the booster and the ship, which will officially achieve full reusability, the holy grail of rocketry. Flight 11 will stress test engines, push the heat shield further, and simulate return maneuvers. It's a high-stakes rehearsal, but it's also the logical next step in SpaceX's rapid development cycle. With all of this in mind, the excitement is undeniable. This flight will not just test hardware, it'll shape the roadmap for future milestones that aim to revolutionize how humanity accesses space. So, are you confident that Flight 11 will succeed? Share your prediction in the comments. Personally, I believe the mission has a 90% chance of success. SpaceX still has a significant amount of work ahead before the next Starship flight can take place. The most pressing priority is completing final work on the vehicles. Super Heavy has already finished nearly all preparations with only the installation of the flight termination system possibly remaining. Meanwhile, the Starship upper stage is undergoing inspections inside Megabay 2. It'll soon need to be outfitted with its payload as well as the flight termination system to ensure full readiness. At the launch site, additional adjustments must be completed quickly to prepare for the arrival of rocket hardware. Every system will need to be inspected thoroughly to minimize the risk of last-minute aborts. Alongside direct launch preparations, supporting infrastructure is also racing to catch up. The Massey test site, for instance, must be brought back online as soon as possible to handle upcoming prototype trials. The first V3 booster B-18 is approaching the end of its production phase and is expected to roll out for testing soon. Following that, the first V3 ship, S-39, will likely be completed within a month. Launch Pad 2 is another critical element that needs to be up and operational quickly. Its testing campaign has to be accelerated because Pad 2 will play a key role not only in supporting Starship launches, but also in enabling the two-stage catching system. Taken together, these tasks mean the period surrounding Flight 11 will be marked by non-stop activity, both in preparation and in the months following. While SpaceX continues to march onward, Firefly Aerospace has encountered new setbacks with its Alpha rocket. Following the mission failure in April, the FAA approved the rocket's return to service after the company addressed the issues. Firefly quickly resumed preparations and scheduled a fresh start. However, during a stage test on the 29th, the Alpha booster exploded at the company's Briggs, Texas facility. Firefly has not released any footage of the incident, but on X, the company confirmed during testing at Firefly's facility in Briggs, Texas, the first stage of Firefly's Alpha Flight 7 rocket experienced an event that resulted in a loss of the stage. The update added that safety procedures were followed, all personnel remained unharmed, and no surrounding facilities were impacted. Still, the delay now appears far more serious. Firefly has not provided a cause for the mishap, but it emphasized its commitment to testing as part of its development approach. Regular testing is part of Firefly's philosophy. We test each critical component, engine, and vehicle stage to ensure it operates within our flight requirements before we ship to the launch pad. We learn from each test to improve our designs and build a more reliable system. The company promised to share more details on its path forward in the near future. This failure casts further doubt on the Alpha rocket's reliability, particularly in its first stage. During the April mission, the booster exploded shortly after separation, which damaged the upper stage engine nozzle, reduced thrust, and ultimately caused payload loss. Firefly attributed that issue to heat buildup from a phenomenon called plume-induced flow separation, a finding accepted by the FAA. However, the September test raises questions about whether those problems were fully resolved or whether deeper issues exist within the vehicle's design or production. Out of Alpha's 6 launches so far, 2 have failed outright, 2 have only partially succeeded, and just 2 have been fully successful. The coming months will be critical in determining whether Firefly can stabilize its systems, or if Alpha risks falling further behind in the competitive small-lift launch market. The ultimate mission for SpaceX as Flight 11 approaches has got to be success. But the path to victory is anything but simple. One of the toughest hurdles, the heat shield. On the last flight, it revealed unexpected discoloration, a clear reminder of just how brutal re-entry can be. Think of it as Starship's armor, standing between the vehicle and fiery destruction. Its strength isn't just important, it's absolutely vital for the future of the entire program. Now, SpaceX is rolling out a bold new upgrade designed to make this shield tougher than ever. If it works, it won't just be an improvement, it could be the breakthrough that changes everything. So just how powerful is this new solution, and why might it be the turning point for Starship's journey into the future? It's now been a full month since Flight 10, and anticipation is building as we approach the highly awaited Flight 11. Yet even as we look forward, many of us still find ourselves reflecting on the heat shield of Ship 37. That striking orange color seen during re-entry left a vivid impression, not only because it was visually unusual, but also because of what it revealed about the system's performance. While it may have created a dramatic spectacle, no one at SpaceX wants to see that particular phenomenon repeat itself. According to Musk, the unusual coloration was the result of oxidation in the metallic tiles. When exposed to extreme heating, the metal reacted and formed iron oxides, which displayed the characteristic orange-red tones. In addition, streaks of white across the surface suggested that coolant had leaked through the gaps between tiles, as well as through the spaces between the tiles and underlying layers. These tiny but critical openings allowed both heat and coolant to escape, which created a serious concern for the integrity of the heat shield system. Although the performance of the heat shield did not directly compromise the overall success of Flight 10, its condition raised important questions about long-term reliability. Even if the vehicle had been recovered by the Mechazilla arms, the heat shield in its damaged state would have been very difficult to reuse. The fundamental purpose of the heat shield is not just to ensure survival through re-entry, but also to make reuse practical and efficient. SpaceX's long-term goal of full reusability depends on a heat shield that is both protective and capable of enduring multiple missions without extensive refurbishment. That is why SpaceX must find and implement effective solutions right away, beginning with Ship 38 for Flight 11. In many ways, the success of Flight 11 depends on solving the problems observed during Flight 10. Musk has even acknowledged that the heat shield is one of the 2 greatest challenges that SpaceX faces in its quest to bring humanity to the plane of being a multiplanetary species. So, what has SpaceX done to address these challenges? One of the most widely discussed solutions is a method engineers are calling the crunch wrap. This approach involves wrapping the tiles with a special type of paper. The wrapping covers the entire base and edges of each tile, with excess material trimmed away after installation. Paper, unlike other materials, offers flexibility and ease of application. Most importantly, this wrapping fills the small but dangerous gaps between tiles. By closing these spaces, the crunch wrap helps block heat penetration, prevents coolant leakage, and ultimately strengthens the barrier protecting the systems beneath the tiles. If successful, this solution will not only prove valuable for Flight 11, but could also become a key feature of future Starship designs. With more than 8 18,000 tiles making up the protective shield, creating a unified and tightly sealed surface is essential. The crunch wrap offers a relatively simple yet highly effective way of turning thousands of individual tiles into a seamless armor. Another major adjustment concerns the metallic tiles themselves. Metallic tiles were originally chosen for their promising potential. They were expected to be more durable, less brittle, and easier to manufacture than ceramic. On paper, these qualities suggested they could reduce costs, increase reliability, and simplify production in the long term. However, Flight 10 revealed a serious drawback. When exposed to the conditions of re-entry, the metallic tiles oxidized heavily, which weakened the shield and raised long-term concerns. Oxidation can slowly degrade the surface, leading to increased refurbishment times, higher risks of failure, and diminished reusability. For these reasons, SpaceX has decided to remove metallic tiles entirely from Ship 38. Eliminating them for Flight 11 allows engineers to avoid the very issue that caused the widespread oxidation problems seen on Flight 10. Still, the question remains, will SpaceX completely abandon metallic tiles, or will they return in the future? Despite their challenges, metallic tiles continue to offer promising advantages. After all, they have only been tested in a single re-entry so far, and it is possible that with improved coatings or protective measures, the problem of oxidation could be mitigated. So, since SpaceX has a history of iterating quickly, and it wouldn't be surprising if metallic tiles reappear in later tests once new solutions are developed. But on the other hand, SpaceX may decide to pursue an entirely new material altogether. We've already seen them test tiles under the blast of extremely powerful flamethrowers, and these experiments may reveal yet another path forward. But what do you think? Will metallic tiles be fully retired, or are they destined for a comeback? The shield's importance only grows with future plans. SpaceX aims to return Starship directly into Mechazilla's chopsticks, a landing that demands a robust, reusable heat shield. To succeed, the system must survive re-entry reliably and with minimal refurbishment, enabling rapid turnaround between flights. Flight 11 is therefore not just another test, it's a pivotal trial of the heat shield itself. Each improvement pushes SpaceX closer to sustainable, repeatable spaceflight. But the heat shield is only one part of the equation. To achieve true success with Starship, SpaceX must also refine and perfect several other critical systems spread across both ship and Super Heavy, ensuring that every component works together to make reusability a reality. Each component plays a role in ensuring the vehicle can survive launch, re-entry, and ultimately achieve reusability. Flight 11 will be another major opportunity to test these systems, refine them, and pave the way toward the next era of the program. One of the most important areas of attention is the flap system. After the upgrades introduced with V2, the forward flaps have shown clear improvements and have generally performed well. However, the aft flaps remain a significant concern. During Flight 10, for instance, stainless steel on the side without tile coverage was observed to peel under stress. This highlighted the vulnerability of the aft flaps, which currently represent one of the most sensitive and fragile parts of the ship. Unlike the forward flaps, they have not seen meaningful design changes, and improving them is proving to be much more challenging. Because of this, extra measures are needed to protect the aft flaps, including reinforcement at their joints and other critical points where damage has already been observed. Protecting the flaps is crucial since they are responsible for slowing down and controlling the ship's trajectory during re-entry. Without reliable flaps, the spacecraft cannot achieve the controlled descent needed for a safe landing. One of the key objectives for Flight 11 will be to demonstrate a controlled landing that equals or surpasses the success of Flight 10, and that will depend heavily on the performance of the aft flaps. Another vital system demanding attention is the engine. Flight 11 will mark the last time Raptor 2 engines are used in a Starship mission before the transition to Raptor 3 begins. The Raptor 2 has already come a long way compared to its earliest versions. In Flight 10, the engines showed significant improvements, with earlier issues such as hardware failures and destructive harmonic vibrations largely resolved. This allowed them to perform reliably throughout the mission, a clear milestone for the program. For Flight 11, the engines must once again prove their capability. Consistency is as important as innovation, and SpaceX needs to show that Raptor 2 can repeatedly deliver reliable performance under real flight conditions. Recent static fire tests have already demonstrated encouraging stability, but a flawless in-flight performance will further validate the engine. In addition to being essential for the immediate mission, this will also set the stage for the arrival of Raptor 3 and for more ambitious objectives, such as the eventual catching of Starship with the Mechazilla arms. Beyond flaps and engines, other subsystems are also in need of attention. These include the regions above the engine bay, the fuel lines, the main tanks, the composite overwrapped pressure vessels, and the payload deployment systems. Each of these areas has shown potential vulnerabilities in past flights. Careful inspection, preparation, and upgrades are necessary to prevent recurring issues. Ensuring these systems operate smoothly will not only support a successful mission, but will also build confidence in the vehicle's ability to handle operational flights in the future. Super Heavy, the massive booster that lifts Starship off the pad, also has its share of improvements to make. In Flight 9, structural issues emerged when the booster had to handle landing at a higher angle of attack, which placed unexpected stresses on its frame. Reinforcing its structure is critical to prevent similar problems in the future. Although the engines on Super Heavy performed well during Flight 10, even completing the landing burn with fewer engines than planned, one engine in the central ring did fail shortly after liftoff. This issue needs to be fully resolved to guarantee reliable performance throughout an entire mission. While the booster's problems are generally more straightforward to identify and fix compared to the complexities of the ship, its performance remains absolutely essential. Super Heavy must function flawlessly to provide the ship with the stable launch and return platform needed to meet SpaceX's long-term goals. In that sense, improvements to Super Heavy are not secondary, but complementary to the success of the overall Starship system. And that brings us directly to Flight 11. This mission isn't just another checkpoint. It's a proving ground where every system must rise to meet higher expectations. The success of Flight 10 has lifted the bar, and now the heat shield, flaps, engines, fuel systems, and booster must all deliver at their best. Above all, the heat shield takes center stage, carrying the weight of Starship's long-term future. If it holds, SpaceX moves one step closer to the extraordinary goal of catching the ship with the Mechazilla arms. If it falters, the path ahead grows steeper. Either way, Flight 11 is set to define the pace of progress. This upcoming flight test is not just another trial. It represents the final chapter of the V2 era before SpaceX transitions to the more advanced V3 generation of Starship. The challenges are immense, but so are the possibilities. If the improvements hold, this mission could validate many of the systems that SpaceX has been refining for years. The flight is only days away. Will SpaceX deliver another success, pushing Starship closer to its vision of full reusability? Either way, the world is watching, and soon we will find out. How will SpaceX bring Starship back to Starbase? That is the question that many people, myself included, have been asking. Now, the path for Starship's return has finally been revealed. SpaceX has officially presented a proposal that outlines how the vehicle will make its way back to the launch site, complete with mapped routes and defined steps. But just how significant is this proposal, and what will SpaceX need to do in order to prepare for this plan? Starship has had a turbulent year filled with challenges, setbacks, and even some high-profile failures. Yet despite all of these difficulties, success finally arrived with Flight 10. This mission marked a turning point for the program and provided renewed confidence in the long-term vision SpaceX is pursuing. While we must be cautious in declaring total success since Flight 11 still lies ahead, the progress that has been made opens up entirely new possibilities for Starship's future. One of the most exciting outcomes is that SpaceX may soon be able to return both stages of Starship to the launch site potentially as early as next year. This would represent the first time the vehicle could perform a full return to its origin point at Starbase in Boca Chica, Texas, rather than being limited to partial reentry paths that terminate elsewhere. However, this raises a critical question. What exact trajectory will Starship take to make this round trip possible? The FAA recently provided an answer. The agency released the Draft Tiered Environmental Assessment, or Draft Tiered EA, for updates to airspace closure for additional launch trajectories and Starship Boca Chica landings of the SpaceX Starship Super Heavy vehicle at the Boca Chica launch site in Cameron County, Texas. The timing of this document is important. If SpaceX intends to land Starship at its launch site, then oversight agencies like the FAA must review and approve the plan in detail before operations can proceed. Within this draft EA, the projected paths for both ship and booster have been outlined. For the upper stage, the simulation imagery reveals its final approach corridor. Starship would begin its re-entry trajectory over the northeast Pacific Ocean, north of the Hawaiian Islands. From there, the corridor stretches east and southeast, gradually narrowing as it approaches the northern regions of Mexico, before ultimately reaching its intended destination of Starbase in South Texas. There are three notable details in this imagery. First, the projected corridor includes two distinct zones, colored red and yellow. The red zone appears to represent the primary route for Starship's descent, while the yellow zone serves as a buffer for extension areas that could be used in the event of navigational adjustments. This layered approach provides added flexibility and ensures that contingencies can be managed safely. Second, the corridor extends over the Mexican mainland, which introduces significant considerations. Overflight raises questions of public safety, environmental protection, air traffic management, and even international diplomacy. For example, the draft EA notes that the affected corridor can contain as many as 200 aircraft per hour. If SpaceX carries out 22 Starship missions annually, this could disrupt between 133 to 200 flights per mission. When projected over a full year, this amounts to approximately 2,926 to 4,400 affected flights. Clearly, mitigation strategies and coordination with aviation authorities will be essential. Third, the endpoint of the warning zone does not terminate directly at Starbase, but rather extends offshore in the Gulf of Mexico. This design suggests that SpaceX is building in the option for an ocean landing in the event of a failure or last-minute safety concern. We saw a similar approach with the Super Heavy booster on Flight 6 when a controlled water landing served as a contingency. Though SpaceX will aim for on-site landings, maintaining this offshore option provides a critical margin of safety. Although not shown explicitly on the FAA maps, one can infer the larger global trajectory that Starship would follow before entering this corridor. The vehicle would likely continue along its current ascent path, reaching orbit via the Atlantic, then transiting across the Indian Ocean and possibly over parts of Southeast Asia or Australia before curving into the Pacific. The maps released focus on the re-entry phase, which is why the final corridor into Texas is illustrated. Another important note is that all planned landings for Starship are scheduled during daylight hours. This decision is most likely a safety precaution because Starship landings are significantly more complex than those of the Falcon 9 or even Super Heavy. Daylight conditions provide the best visibility for both ground teams and tracking systems. Turning to Super Heavy, the FAA assessment reveals additional layers of detail. The booster, of course, begins its journey at Starbase and departs over water. Rather than remaining confined to the Gulf of Mexico, the planned trajectories extend outward into the Atlantic Ocean. Interestingly, two distinct corridors are under consideration. One points northeast, passing over Florida and out into the open Atlantic, while the other heads southeast through the narrow strait between Mexico and Cuba, continuing past Jamaica before entering the Atlantic. This dual option approach indicates that Super Heavy may follow different paths, depending on the specific mission profile or environmental conditions. However, just like with Ship, these routes introduce significant air traffic considerations. According to the FAA's analysis, the booster's operational area also averages 200 aircraft per hour. With 22 annual launches, each event could impact between 133 and 400 flights. That results in an annual total of roughly 2,926 to 8,800 potentially affected flights. These numbers exceed those of Ship's return corridor, which makes sense given the higher air traffic density in the eastern Atlantic regions. Furthermore, the FAA highlights a unique distinction between Ship and booster returns. While Ship landings will not take place at night, Super Heavy landings may occasionally be scheduled after dark. The plan allows for approximately 3 night operations per year. During those periods, air traffic density would be lower, averaging about 10 flights per hour in the relevant airspace. Even so, each nighttime landing could disrupt between 7 and 120 flights, resulting in an annual total of 21 to 360 affected flights. It's clear that extensive debate, consultation, and collaboration will be required before these plans are finalized. The FAA, SpaceX, and other stakeholders must address questions of air safety, environmental protection, and international cooperation. However, the very existence of this proposal reflects a growing confidence within SpaceX. The company is not only envisioning but actively preparing for full return to launch site operations. If realized, this capability would represent a monumental milestone. Full reuse with both ship and booster returning directly to Starbase would establish a new standard for spaceflight operations. The frequency of missions could dramatically increase, while costs would continue to fall. These factors are at the core of SpaceX's long-term strategy to make humanity multiplanetary. The road ahead will not be simple. Regulatory approvals, technical refinements, and operational rehearsals must all take place before the first full return to Starbase is attempted. Yet the draft EA shows us that the framework is already being built. The vision is clear, and the pieces are falling into place. So do you believe that SpaceX's proposed return paths for Starship will become reality in the near future? Reply with the number 1 in the comments to let me know. And as always, remember to like the video and subscribe to the channel so you can continue following the incredible journey of SpaceX and Starship. Right now, the central questions surrounding Starship are all about progress and preparation. Musk recently revealed that a major milestone flight could take place between Flight 13 and 15, depending heavily on the outcome of Flight 12. In reality, even the results of Flight 11 will play a role in shaping this timeline. At the current pace of roughly one launch every 2 months, we could see this attempt occur early next year. However, the road to that point involves a tremendous amount of work. One of the most pressing challenges is safety. Starship's projected flight path will carry it over densely populated urban areas as well as key maritime straits that serve as lifelines for global shipping. To proceed, SpaceX will need to demonstrate that the vehicle poses minimal risk to both people and infrastructure. Achieving this will require rigorous testing, detailed simulations, and close cooperation with the Federal Aviation Administration. Domestic environmental agencies will also play a major role as they must assess potential impacts to ecosystems and communities. The complexity increases further when we consider international involvement. Starship's path will cross territories that include Mexico and regions of the Caribbean. Past negotiations with Falcon 9 landings in the Bahamas highlight just how delicate such agreements can be. Even though Falcon 9 is much smaller than Starship, agreements proved difficult and ultimately stalled. With a vehicle of Starship's size, the stakes are far higher. Even a relatively minor issue, such as a heat shield tile being shed mid-flight, could create significant concerns for both safety and liability. The second major preparation involves mastering flight procedures. Operational consistency is the only way to convince regulatory bodies and partner nations that Starship is ready for routine flights. While Flight 10 was a remarkable success, many challenges remain. Some flights have failed to reach orbit. Engine issues have surfaced at different stages of ascent, heat shield imperfections and occasional leaks have appeared, composite overwrapped pressure vessels, or COPVs for short, have also been problematic on multiple missions. Each of these failures provides lessons, but they must be corrected and validated before the program can move forward confidently. The next 2 flights later this year will be crucial. SpaceX will need to resolve lingering issues while progressively increasing mission complexity. This could involve carrying heavier payloads, flying with operational cargo, performing more aggressive re-entry angles to conserve fuel, or fine-tuning the precision of landing burns. Each step will push the system closer to readiness for full-scale reusability. Vehicle upgrades are another critical factor. The transition to Starship V3 will bring significant changes. This version is being designed with the catch system in mind, incorporating upgrades to the engines, heat shield, and other systems that directly impact reusability. These enhancements are not just theoretical but must be proven in flight. SpaceX will likely rely on Flight 12 as the debut mission for V3, using it to validate these upgrades before attempting more ambitious recoveries. Finally, none of this can happen without ground systems operating at full capacity. At least 2 launch towers with functional Mechazilla arms are required to attempt simultaneous catches of both the Super Heavy booster and the Starship upper stage. Pad 2 is close to being ready, with operations expected to begin around Flight 12. Pad 1 will undergo significant upgrades, including modifications to its chopsticks, orbital launch mount, and defensive systems. These upgrades must be finished quickly, particularly for handling the ship stage, in order to meet SpaceX's ambitious goals. In short, the path ahead for Starship is demanding but achievable. The next several flights will determine whether the program is truly ready to move from experimental tests into operational capability. If SpaceX can resolve technical issues, validate upgrades, and secure regulatory trust, then the vision of catching and reusing both stages of Starship may soon become reality. And now SpaceX stands on the brink of yet another groundbreaking milestone in the aerospace industry. While much of the world is still working to replicate Falcon 9's reusability or struggling to bring even small components back safely, SpaceX is preparing to attempt something far more ambitious. Their goal is nothing less than to establish a new standard, the full and rapid reusability of Starship. As early as next year, both stages of Starship could return from orbit, fulfilling the vision SpaceX has pursued for decades. The challenges are immense, from engineering hurdles to regulatory approvals, yet this is not unfamiliar territory for a company that has consistently turned the impossible into reality. The path is now outlined, and the team is working tirelessly to bring it to life. Are you ready to witness what could be remembered as the return of the king in SpaceX's Starship era? When people hear the phrase "gateway to Mars," they often picture Starbase, Texas. Yet SpaceX has another path to the future of Starship, and it lies in Florida, the very heart of the space industry. Here, construction of the first Starship launch pad in the region has reached a major milestone, with progress on the flame trench signaling new potential for what lies ahead. So how far has SpaceX come with the Florida launch pad, and what remains to be done before the system is ready to operate? The evolution of Starship's ground systems is perhaps one of the most visible signs of SpaceX's relentless drive toward improvement. At Starbase, the transition from Pad 1 to 2 already illustrates how quickly lessons are applied. At Starbase, the transition from Pad 1 to Pad 2 already illustrates how quickly lessons are applied and designs are upgraded. Yet beyond Texas, there's another site undergoing a similar transformation. At Kennedy Space Center in Florida, Launch Complex 39A is beginning to mirror that same leap forward. Pad LC-39A has a long and storied history. It was the site of many Apollo and Shuttle missions, and more recently, Falcon 9 and Falcon Heavy launches. For Starship, the pad was equipped with a launch tower, chopsticks, an OLM, and a range of other subsystems. However, the first version of its OLM imitated the six-legged model of Pad 1 at Starbase. That design, while innovative, carried limitations that became clear after testing. Last year, in the middle of ongoing construction, observers noticed something surprising. The OLM legs at LC-39A were dismantled and removed. At first, the decision seemed abrupt, but the reasoning soon became clear once Pad 2 at Starbase was completed. The redesign at Florida is not a step backward, but rather a step toward the same new standard of infrastructure that Pad 2 represents. LC-39A is now set to feature a completely new OLM and a flame trench, echoing the upgraded design philosophy that SpaceX has embraced in Texas. Since that decision, renovation work at the site has moved forward steadily. At the location of the old OLM, the ground was dug out to make way for a flame trench. Workers then installed rebar and poured concrete, laying the foundation for the new system. Once that preparation was complete, a major milestone was reached. On September 27th, two massive sections of the flame bucket were lifted by crane and lowered into position. Following this step, another concrete pour will likely secure the buckets into the structure permanently. The moment is a clear reflection of SpaceX's momentum. A nearly identical step was carried out at Starbase back in April, and now, just 5 months later, the same procedure is being repeated in Florida. The pace is not only quick, but also efficient, largely because Florida benefits from the lessons already learned in Texas. Unlike Pad 2 at Starbase, where every component had to be built from scratch, LC-39A already had a launch tower in place, cutting down construction time significantly. The flame trench design at Florida is nearly identical to that of Pad 2. Each trench consists of two L-shaped flame buckets built from rows of tightly joined pipes grouped into three main sections, with a crossbar connecting the top. The use of two flame buckets rather than one greatly enhances heat and pressure dissipation during static fire tests and launches. Recent deluge system testing at Pad 2 has already demonstrated the effectiveness of this design, while earlier experiments at the Massey test site with just a single flame bucket showed promising results despite operating on a smaller scale. Compared to the earlier water-cooled steel plate system at Pad 1, this trench system is a clear upgrade. The plate was designed to absorb and withstand the sheer force of Starship's engines by spraying water upward, but it quickly showed wear. Within only a few flights, the reverse shower effect stained and altered the plate, proving that the system would require frequent refurbishment or eventual replacement. While the plate did its job, it was not sustainable for long-term operations. In contrast, the trench system directs the energy away rather than absorbing it all. By combining the physical deflection of the flame bucket with powerful water flow, the system is designed to endure repeated use with far less maintenance. This makes it not just a short-term fix, but a solution built for the future. And the future will demand it. Musk has spoken of ambitious operational goals, such as Starships flying daily, while Super Heavy boosters launch as often as every hour. In order to reach such cadence, ground systems must be robust enough to withstand relentless use without downtime for repairs. At the same time, the rockets themselves are growing more powerful. Current Starship vehicles generate around 7,000 tons of thrust at liftoff, but the coming V3 version with upgraded Raptor 3 engines will exceed 9,000 tons. In the longer term, SpaceX aims for Starship to surpass 10,000 tons of thrust, a staggering figure that will demand equally powerful infrastructure. LC-39A's new trench and OLM are being built with these goals in mind. The progress at Florida is also part of a broader roadmap. After LC-39A and Pad 2 at Starbase are fully operational, SpaceX plans to upgrade Pad 1 at Starbase as well, likely beginning after Flight 11. Additional facilities such as SLC-37 are also on the horizon. Each new system will reflect the lessons of its predecessors, standard across the entire launch network. In just a few years, the groundwork is being laid for a future where rockets as powerful as Starship launch at a cadence never before imagined. And it all begins with milestones like the trench installation at LC-39A. So, as SpaceX continues to refine and upgrade its infrastructure, show your support by commenting "refine and optimize." And don't forget to like the video and subscribe to our channel to stay up to date on the next steps in Starship's incredible journey. Of course, SpaceX still has a significant amount of work ahead before the LC-39A launch pad is truly operational. The installation of the flame bucket is only the beginning of a long sequence of steps, each requiring immense engineering precision and coordination. Once this crucial milestone is completed, the focus will inevitably shift to the most complex component of the pad system, the orbital launch mount, or the OLM, as I've been saying the whole time. The OLM is expected to take the form of a massive box-shaped structure, similar to what we've already seen at Pad 2 in Starbase. Constructing this feature will undoubtedly be a time-consuming process, just as it was in Texas. The work involves multiple highly technical stages, including the assembly of the steel framework, integration of the powerful hold-down clamp arm, installation of the intricate plumbing networks, and the careful addition of support legs. After the OLM has been fully established, it'll be transported to the launch pad and welded securely into place. Given the pace of progress, it is reasonable to predict that this structure could begin to take shape around November or December. At the pad itself, the area surrounding the flame trench will first need to be raised to form the base for the OLM. Following that, SpaceX will construct the Booster QD gantry frame, which will eventually support the Booster QD system. Once this is installed, the next major task will involve developing a complex network of pipes to connect the launch pad systems to the adjacent tank farm, ensuring that propellant and cooling fluids can be delivered safely and efficiently during operations. Once these essential systems are in place, the first major pad verification tests will likely begin. We can expect to see dramatic water jet testing on LC-39A, very similar to the tests recently conducted at Pad 2 in Starbase. These tests are designed to simulate the massive acoustic and thermal loads that will occur during launches, ensuring that the flame trench and deluge system can withstand the extreme conditions. However, testing the water systems alone will not be enough. SpaceX will eventually need to run full-scale trials with actual Starship prototypes, including static fire tests of a fully loaded Super Heavy booster with all 33 Raptor engines firing at once. These will be critical steps in confirming the pad's readiness for operational launches. Meanwhile, another crucial component, the chopsticks system, must also reach completion. This gigantic mechanism will serve multiple functions, such as stacking Starship onto Super Heavy, supporting the vehicle during operations, and ultimately even attempting stage capture during booster landings. Unless SpaceX develops an entirely new and separate capture mechanism, the chopsticks at LC-39A will likely be among the first subsystems to be brought online. In fact, LC-39A's upgrades extend beyond its flame trench OLM and chopsticks. For now, Florida lacks Starship production, requiring vehicles to be shipped from Texas. To close this gap, SpaceX has begun building a Florida Gigabay for assembly and is expected to pursue a Star Factory for full-scale manufacturing, though that will take time. In the end, the message is clear. A launch pad alone is not enough. Without factories, transport, and logistics, its potential remains limited. If these systems mature together, LC-39A SL-39A could become the backbone of daily Starship flights, driving SpaceX's vision of rapid, reusable space travel. Overall, extensive preparations will be essential to secure a strong future for Starship operations in Florida. Beyond the massive work already underway at LC-39A, SpaceX has also set its sights on SLC-37, which, according to simulations, could eventually support at least 2 Starship launch pads, with the possibility of even more being added over time. Together, these two complexes form the cornerstone of a truly ambitious plan, one that reflects SpaceX's vision of rapid, high-frequency Starship launches on a scale the world has never seen. Why, the numbers alone are staggering. LC-39A is projected to host 44 Starship launches per year, while SLC-37 could reach an astonishing 76. Although LC-39A's flight rate may remain capped due to the proximity of ongoing Falcon 9 operations, SLC-37 has far fewer constraints and could continue to scale up even further. At least for the near term, this means Florida's launch cadence would surpass even that of Starbase in Texas, which until now has been considered Starship's primary home. This shift highlights Florida's growing strategic importance in SpaceX's roadmap. Although facilities in the region are being developed later than those in Texas, Florida is expected to play a central role in missions tied to NASA, particularly those connected to Artemis. Starship will serve not only in direct lunar missions, but also in the vital refilling operations required to make them possible. In the longer term, the establishment of a lunar base will demand dozens of follow-up flights, ensuring a steady stream of Starship activity from Florida. Beyond NASA, the pads here will also support U.S. military and government missions, setting them apart from Starbase, which is likely to focus more on Mars-oriented campaigns and the broader commercial market. Landings will be just as critical as launches, and Florida will see unprecedented traffic in this regard. Since the ultimate goal is to recover both stages, the number of landings will double the number of launches. Recovery methods will vary, including dramatic captures with the Mechazilla arms, as well as landings on the ocean-going drone ships. Such variety and scale of recovery operations have never been attempted with any rocket system before. What SpaceX is building in Florida is nothing short of historic. Starship promises to create a launch and landing rhythm so intense and so complex that it'll make even Falcon 9's record-shattering achievements look modest by comparison. With only 4 pads, Falcon 9 has already dominated global launch markets, but with Starship's expanded network and extraordinary cadence, SpaceX is poised to achieve a level of activity that will utterly overwhelm competitors and redefine the future of spaceflight. For me, it's safe to say that a powerful Starship future is steadily unfolding in Florida. Ambitious launch and landing plans have already been mapped out, and to prepare for this vision, the launch pads are undergoing continuous upgrades designed to support a much higher frequency of operations. At the center of this transformation is Pad LC-39A, which has now reached a significant milestone with the official installation of key sections of its flame trench system. From here, many more steps will follow, each bringing its own set of challenges that SpaceX must overcome before activating these new and incredibly capable launch points. Yet, if history has shown us anything, it's that this team thrives on solving the impossible. With such potent infrastructure as a foundation, Florida will soon stand as one of, if not the, world's busiest spaceports, pushing Starship toward goals that once belonged only to imagination. So perhaps it's time to look skyward once again and ask ourselves, which target should humanity aim for next? Disappointing. That's perhaps the most fitting word to describe Dream Chaser at this moment. Once viewed as a vehicle full of promise, the latest contract update between NASA and Sierra Space marks a significant setback for this ambitious space plane. It's now becoming increasingly clear that the ability of Dream Chaser to compete with SpaceX's Dragon is growing more and more unrealistic. So how exactly has the plan for Dream Chaser changed, and why does it represent such disappointment? After that, we turn our attention to the upcoming ULA Atlas V mission that will carry Kuiper satellites to orbit, as well as a fascinating new discovery made by the James Webb Space Telescope when it viewed Saturn. Dream Chaser, with its distinctive spaceplane design and runway landing capability, has long stood out as one of the most intriguing spacecraft in development. Production of the first vehicle, named Tenacity, was completed in late 2023, and its test campaign campaign in the following months delivered encouraging results. These milestones inspired optimism that Sierra Space was finally on the verge of delivering a new competitor in the field of orbital transportation. Yet as we move through the second half of 2025, one truth overshadows every achievement. Dream Chaser has still not flown. The biggest question surrounding the program is no longer about design or testing, but rather about timing. When will Dream Chaser actually launch? And unfortunately for those who placed their trust in this vehicle, the answer that has just been given is not one that inspires confidence. NASA and Sierra Space recently confirmed that they have modified the original contract governing Dream Chaser's flights. The official NASA update stated, "After a thorough evaluation, NASA and Sierra Space have mutually agreed to modify the contract as the company determined Dream Chaser development is best served by a free flight demonstration targeted in late 2026. This means there will be no Dream Chaser launch in 2025 as some had predicted. Even worse, it's not scheduled for early 2026 either, but rather late in the year. That creates a gap of at least another year before Dream Chaser makes its debut. No firm date has been announced. NASA further clarified in the update, Sierra Space will continue to provide NASA with insight into the development of Dream Chaser, including through the flight demonstration. NASA will provide minimal support through the remainder of the development and the flight demonstration. Compared to the original timeline, this is a massive delay and one that raises troubling questions about Dream Chaser's future. The first mission with the Tenacity prototype was to carry cargo to the ISS, followed by a second cargo flight using the next vehicle, Reverence. Only on the third flight after 2 years of testing was Dream Chaser expected to introduce a crew-rated prototype. If the first mission now slips into late 2026, the subsequent milestones are pushed further back as well. Realistically, this could mean that a crewed Dream Chaser flight might not occur until 2028 or 2029, and that assumes everything goes smoothly. Any complications could push the timeline even further. The clock is not on Dream Chaser's side. The International Space Station is currently scheduled to remain in operation until around 2030 or 2031, which leaves only a narrow window of opportunity for Dream Chaser to provide meaningful service. By the time the space plane is proven flight-worthy, the station could already be nearing the end of its life, leaving little time for Dream Chaser to fulfill its original purpose. This schedule slip also comes with a significant change in Dream Chaser's contract requirements. Under the previous agreement, Sierra Space was obligated to perform at least 7 resupply flights to the ISS. NASA had already issued firm task orders for 4 of those missions. With the revised contract, however, NASA is no longer obligated to order a set number of flights. Instead, the agency may request missions only after a successful free flight demonstration. In effect, Dream Chaser's future role has shifted from being a guaranteed ISS resupply vehicle to something more uncertain and conditional. Sierra Space attempted to put a positive spin on the announcement. In a post on X, the company said the free flight demonstration is intended to prove the technology and deliver critical data to NASA while also providing the flexibility to support national security and commercial opportunities. On its official page, Sierra Space explained that the flight will aim to demonstrate critical capabilities for NASA's ISS resupply and future commercial LEO destinations missions and position Dream Chaser as a national asset available for national security and defense demonstrations. But despite these words, the setback is obvious. So why has Dream Chaser fallen so far behind? Dana Weigel, NASA's ISS program manager, acknowledged the broader challenge. Development of new space transportation systems is difficult and can take longer than originally planned. The ability to perform a flight demonstration can be a key enabler in a spacecraft's development and readiness, as well as offering greater flexibility for NASA and Sierra Space. As NASA and its partners look toward space station deorbit in 2030, this mutually agreed upon decision enables testing and verification to continue on Dream Chaser as well as demonstrating the capabilities of the spaceplane for future resupply missions in low Earth orbit. Dream Chaser's struggles run deeper than official statements suggest. While production finished on time and testing showed promise, the spacecraft has been slowed by conflicts with its launch provider, ULA's Vulcan Centaur. When Vulcan was available, Dream Chaser wasn't ready. When Dream Chaser neared readiness, Vulcan faced technical issues or prioritized national security launches. With ULA now facing a backlog, Dream Chaser has repeatedly missed flight opportunities, stalling its momentum. Combined with delays and the shrinking timeline before the ISS retires, Dream Chaser's outlook is far less competitive than once hoped. After Boeing's Starliner stumbled through years of setbacks, many expected Dream Chaser to emerge as a challenger to SpaceX's Dragon. Its lifting body design promised unique benefits, such as a runway landing for rapid cargo return. But as of 2025, Dragon dominates. It has flown numerous crew and cargo missions with flawless crewed flight records and unmatched flexibility, stepping in whenever Starliner faltered. NASA continues to rely heavily on Dragon for both ISS operations and future commercial station plans. In contrast, Starliner has contributed little. Cygnus has faced challenges, and Dream Chaser has yet to debut. Dragon stands virtually alone as America's proven spacecraft. This leaves Dream Chaser in a diminished position. Its chance to compete directly with Dragon is slipping away, and its role at the ISS remains uncertain. More likely, it will serve Sierra Space's planned commercial station or find a smaller role within broader commercial LEO destination efforts. For now, the future is obscure, and the optimism that once surrounded Dream Chaser has dimmed. Its first flight will test not just technology, but relevance. So, what do you think? Are NASA and Sierra Space's contract changes for Dream Chaser a failure or a necessary step to keep the program alive? Let me know with a yes or a no in the comments, and don't forget to like the video and subscribe to follow SpaceX's journey. In the meantime, at 8:09 a.m. Eastern on September 25th, ULA successfully launched an Atlas V rocket from Cape Canaveral carrying 27 Amazon Kuiper satellites into orbit. The mission marked another important step in the deployment of Amazon's ambitious Project Kuiper satellite constellation, which is designed to bring global broadband internet coverage. Following liftoff, the Atlas V's upper stage deployed the satellites into an initial orbit at an altitude of 280 miles or about 450 kilometers. After separation, Amazon's Project Kuiper team officially assumed control of the satellites from its Mission Operations Center in Redmond, Washington. According to Amazon, the team will first confirm the health of the spacecraft before gradually raising them to their operational altitude of 392 miles or roughly 630 kilometers above Earth. This was the fifth Kuiper launch mission to date, and the third conducted using ULA's Atlas V. The remaining two were carried out by SpaceX Falcon 9 rockets. With this mission, a total of 129 Kuiper satellites have now been placed into orbit. While the number may sound impressive, it represents only the very beginning of a much larger effort. The full Project Kuiper constellation is expected to include approximately 3,200 satellites in low Earth orbit. To build out this massive network, Amazon has contracted more than 80 launches across multiple providers, including SpaceX's Falcon 9, Arianespace's Ariane 6, Blue Origin's upcoming New Glenn, and ULA's Atlas V and Vulcan Centaur. The latest mission flew on the Atlas V 551, the rocket's most powerful variant, using 5 solid boosters to lift a heavy batch of Kuiper satellites. But Atlas V is nearing retirement. With only one more Kuiper launch left, the rest are reserved for Boeing's Starliner. Unless ULA reallocates flights, Atlas V's role in Kuiper will remain small. That puts pressure on ULA to bring Vulcan Centaur online. Vulcan is slated to handle most Kuiper launches, yet its delays have already caused setbacks, including pushing back Sierra Space's Dream Chaser. For now, the success of this Atlas V mission underscores both progress and urgency. Kuiper is still in its early stages, and its future hinges on a steady launch cadence. The real test will be how quickly ULA can shift from Atlas V to Vulcan while meeting its broader commitments. With thousands of satellites still to fly, the story of Kuiper and ULA's role in it is just beginning. And for our last segment of today's updates, the James Webb Space Telescope has turned its gaze closer to home, unveiling mysterious new features in the skies of Saturn, the planet often hailed as the jewel of the outer solar system. These latest observations have revealed phenomena that scientists have never seen on any other world, making Saturn an even more fascinating subject of study. The telescopes detected what astronomers are calling dark beads scattered across Saturn's glowing auroras, as well as a star-shaped pattern with 2 mysteriously missing arms. These strange phenomena immediately caught the attention of the scientific community. Tom Stollard, an astronomer at Northumbria University in the UK who led the study, described the discovery by saying, "These features were completely unexpected and, at present, are completely unexplained." Auroras are natural light shows created when charged particles interact with a planet's magnetic field and atmosphere. On Earth, they appear as the shimmering northern and southern lights. eclipse. But on Saturn, auroras are on a much grander scale, stretching thousands of miles across the poles. Scientists believe that studying these odd new features could provide critical insights into how Saturn's magnetic bubble, or magnetosphere, exchanges energy with its atmosphere, fueling its dazzling auroras. Scientists are still unsure whether the beads and the star-shaped feature are linked or if their simultaneous appearance is simply coincidence. Stollard himself noted the oddity, emphasizing that more analysis is needed before any firm conclusions can be drawn. While the cause remains a mystery, these discoveries highlight just how dynamic and complex Saturn's atmosphere and magnetosphere truly are. Saturn has long inspired both scientific curiosity and public wonder with its rings and its vast system of moons. Now, with the help of Webb, the planet has grown even more intriguing. For now, these findings are another reminder of the power of space telescopes to transform our understanding of distant worlds. Webb can only observe from afar, but many scientists hope that in the future, uncrewed probes or even crewed spacecraft will venture to Saturn to study these phenomena directly. Until then, we can only marvel at the beauty and mystery revealed in these latest glimpses of the ringed giant. In any case, folks, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.